Hello, so in today's class we'll look at what is called a regular singular point. So consider the second order differential equation y double dash plus p of x y dash plus q of x y equal to 0. So here if the functions p and q are analytic, so if you have a point x equal to x naught, so it is said to be an ordinary point if your P and Q are analytic at, so they must be analytic at x equal to x naught. Now, if they fail to be analytic at x equal to x naught, we call x naught as a singular point. So, the point x naught is called a singular point of the differential equation. So we have the above differential equation y double dash plus p of x y dash plus q of x y equal to 0 if one or the other, or you can have both the functions p and q, one or the other or both of the coefficient functions p of x and q of x fails to be analytic at x equal to x naught. So such a point is called a singular point. So for example, consider the equation y double dash plus 2 by x y dash minus 2 by x square y equal to 0. So if you take x equal to 0, you can see that so the coefficient functions are 2 by x and q of x is minus 2 by x square. So at x equal to 0, the functions p and q are not analytic. They are not analytic. So here x equal to 0 is a singular point. So this is how we define a singular point. Now let us define what is a regular singular point. Now a singular point x equal to x naught is said to be regular if the functions, so when you take the functions x minus x naught into p of x and x minus x naught whole square into q of x, so this must be analytic. So x minus x naught into p of x and x minus x naught whole square into q of x are analytic. If it is so, then the point is said to be a regular singular point and it is said to be irregular otherwise. So that is how we define a regular singular point. So let us see an example of a regular singular point. So consider the Legendre's equation. So when you take the Legendre's equation, that is y double dash minus 2 by x into 1 minus x square y dash plus p into p plus 1 minus x square y equal to 0. So if you look at the denominator, p in denominator you have x square minus 1. So clearly the points x equal to 1 and minus 1 are singular points. Now when you take x minus 1 into p of x, so consider the point x equal to 1. So we will check what is the nature of the point x equal to 1. So when you take x minus 1 into p of x, that is minus 2x by so you will get plus 2x by x plus 1 and x minus 1 whole square into p of x will be you will get p into p plus 1 by, so x minus 1 or x minus 1 cancel out. So you will have minus of 1 plus x in the denominator. So you can see that when x is equal to 1, these functions are analytic. 2x by x plus 1, x equal to 1 il analytic aanu. Aduvole ee function edukkumbozhum x equal to 1 il analytic aanu. So x minus 1 into p of x and x minus 1 whole square into p of x are analytic at x equal to 1. So therefore x equal to 1 is a regular singular point. And similarly, if you take x equal to minus 1, you will get the same result. So x equal to minus 1 also, that is also a regular singular point. Similarly, x equal to minus 1 is a regular singular point. Now if you consider the equation, so if you consider the Bessel's equation, so Bessel's equation of order p, so that is equation x square y double dash plus xy dash plus x square minus p square y equal to 0. So that is y double dash plus y dash by x square plus x square minus p square y by x square equal to 0. So clearly x equal to 0 is a singular point because the component functions fail to be analytic at, coefficient function fails to be analytic at x equal to 0. Now if you take x into p of x, that is equal to 1, and x square into q of x will be x square minus p square. So therefore you can see that x equal to 0 is a regular singular point. So here regular singular point. So let us see a few more examples on finding the nature of the singular points. So for each of the following differential equations, locate and classify its singular points on the x-axis. So here x cube into x minus 1 y double dash minus 2x minus 1 y dash plus 3xy equal to 0. So the equation can be rewritten as y double dash minus 2 by x cube y dash varum plus 3y by x square x minus 1 equal to 0. So here p of x is minus 2 by x cube and the q of x is 3y by x square into x minus 1. So clearly at x equal to 0 and x equal to 1, functions are not analytic. So x equal to 0 and 1 singular points. Now when x is 0, so take x into p of x. X into p of x is minus 2 by x square and x square into q of x is 3y by x minus 1. So it fails to be analytic. So therefore x equal to 0 is an irregular singular point. So it is an irregular singular point. Now consider, now we need to look for 1. So consider x minus 1 into p of x and x minus 1 whole square into q of x. So x minus 1 into p of x will be minus 2 by x cube. So minus 2 by x cube into x minus 1 varum the 3y by x square 3y by x square into x minus 1. So here x minus 1 p of x and x minus 1 whole square q of x are analytic at x equal to 1. So therefore, we can conclude that x equal to 1 is a regular singular point. But here x equal to 0 is an irregular singular point. Let us see one more example. So the second example is 3x plus 1 x y double dash minus x plus 1 y dash plus 2y equal to 0. So we can rewrite the equation as y double dash minus x plus 1 by x into 3x plus 1 y dash plus 2y by sorry, here the y ഇവിടെ ഇല്ല, q എടുക്കുമ്പോൾ y എടുക്കില്ല. So please make that correction. ഞാൻ എവിടെയും ആ y എഴുതിയിട്ടുണ്ട്. Okay. Please make that correction in the previous problem. q എടുക്കുമ്പോൾ 3 by x square into x minus 1 ആണ്. So that is 2y by x into 3x plus 1 equal to 0. So here x equal to 0 and minus 1 by 3 are singular points. And p of x is minus x plus 1 by 3x plus 1 into x, and q of x is 2 by x into 3x plus 1. So when you take x into p of x, so that is minus x plus 1 by 3x plus 1, and x square into q of x is 2x by 3x plus 1. So these are analytic. So therefore x equal to 0 is a regular singular point. And if you take x minus 1 by 3, അടുത്ത singular point എന്ന് പറയുന്നത് minus 1 by 3 ആണ്. So take x plus 1 by 3 into p of x and x plus 1 by 3 whole square into q of x. So that will be equal to നമുക്ക് 3x plus 1 cancel ആവും, minus x plus 1 by 3 വരും ഇവിടെ, 3x, and here you will get minus 2. So here you will get 2 by x into denominator 9 varum, again numerator like 3x plus 1 varum. So these both functions they are, so these are analytic at x equal to minus 1 by 3. So therefore x equal to minus 1 by 3 is a regular singular point. And now let us look at one more question. So, determine the nature of the point x equal to 0 for the following equations. So, first we have y double dash plus sin x y equal to 0. So if you look at p of x is equal to sin x and the q of x is equal to 0. So the function sin x is analytic for all x. So therefore there are no singular points. So therefore x equal to 0 is an ordinary point. Now similarly, I need you to do a few more problems, identify whether the points are ordinary points, then regular or irregular singular points. So for these 3 questions, identify what is the nature of x equal to 0. Ordinary singular, ordinary point ano, regular ano, irregular ano, identify. So please work out these problems in your